Positive numbers are defined as any numbers that are greater than 0. They represent quantities that have a value above the neutral point of 0. Common examples of positive numbers include 1. The smallest positive integer. 5. A common example used in basic counting. 10. Often used in everyday context, such as scoring in games. 20.5. A positive decimal number, illustrating that not all positive numbers are whole numbers. 3/4. A positive fraction, showing that positive numbers can also be expressed as fractions. Positive numbers can be whole numbers, integers, fractions, or decimals. They are essential in various real-world contexts, such as measuring distance, height, or quantity. Negative numbers. Negative numbers are defined as any numbers that are less than 0. They represent quantities that fall below the neutral point of 0 and often indicate a deficit or a loss. Common examples of negative numbers include -1 represents a loss of 1 unit. -3.5, a negative decimal number, indicating a value below 0. -15/4, a negative fraction, illustrating that negative numbers can also be expressed as fractions. Similar to positive numbers, negative numbers can also be whole numbers, fractions, or decimals. They are crucial for understanding concepts such as temperature changes, financial losses, and other scenarios where values can drop below 0. 0. 0 is defined as the numeral or symbol 0, representing the complete absence of any quantity or magnitude. It serves as a crucial point in mathematics and is recognized for its unique properties. 0 acts as the point that separates positive numbers from negative numbers. It is neither positive nor negative. 0 is also known as the additive identity in mathematics, meaning that adding 0 to any number does not change the value of that number. For example, x plus 0 equals x. Placeholder. In decimal notation, 0 serves as a placeholder, indicating that certain values do not contribute to the overall value. For example, in 205, the 0 signifies there are no tens. 0 plays a fundamental role in mathematics and everyday life. It represents the absence of quantity, serves as a critical reference point on the number line, and facilitates various mathematical operations. Opposite quantities. The concept of opposite quantities refers to pairs of values that have equal magnitude but opposite signs. In mathematics, this means that for every positive quantity, there exists a corresponding negative quantity that represents the opposite value. For example, +3 and -3 are opposites. More generally, if x is a positive number, then -x is its negative counterpart. In financial contexts, credits and debits can be seen as opposite quantities. A credit, money received, is represented as a positive number. A debit, money spent or owed, is represented as a negative number. For instance, if you have a credit of $100 plus 100 and a debit of $50 minus 50, your net balance can be calculated as 100 plus minus 50 equals 50. Positive numbers have been recognized since ancient civilizations, such as the Egyptians and Babylonians. These cultures utilized counting systems that included positive integers for trade, measurement, and record keeping. The concept of positive numbers was fundamental to their mathematical practices and daily life. However, the acceptance of negative numbers came much later. Negative numbers were first mentioned in China around 200 BCE, where they were used in a counting system to represent debts. However, their systematic treatment is attributed to the Indian mathematician Brahmagupta in the 7th century CE, who established rules for arithmetic operations involving negative numbers in his work, Brahmafusas ad Danton. Despite this, negative numbers face considerable resistance in Western mathematics. In Europe, many mathematicians regarded negative solutions as illogical for centuries. This skepticism persisted until the 15th century, when scholars began to study and translate ancient texts that acknowledged negative numbers. It was not until the 17th century that mathematicians like John Wallis introduced the concept of the number line, which helped clarify the relationship between positive and negative values. The eventual acceptance of negative numbers revolutionized mathematics by enabling more complex calculations and paving the way for advancements in algebra and calculus. Today, negative numbers are integral to various fields, demonstrating their enduring significance in mathematical theory and practical applications. The concept of zero has a rich history as well. It was developed earlier in India, where Brahmagupta treated it as a number rather than merely a placeholder. Nevertheless, the acceptance of zero in Europe occurred much later during the Renaissance period, 14th to 17th centuries. Mathematicians like Fibonacci began to recognize zero's importance in calculations, which ultimately transformed mathematical thought. Thank you for watching this video. In our next video, we will delve into rational numbers as well as its interesting history. If you enjoyed this video, please like and subscribe to our channel for more mathematical content. We also welcome your thoughts and questions in the comments section below. See you.